so comparing numbers in scientific notation. Again, pause the video to get everything written down, and then we will fill in the blanks as we're going through it. So if you look, if we were comparing 6.23 times 10 to the 14th and 8.9112 times 10 to the 12th. So if we were looking at these two numbers, talking about which one was more, like if we were talking about population and you were wanting to know which population of a country was larger, then you would need to think about these two numbers and just think about the exponents and all of that. So to compare two numbers given in scientific notation, first compare the exponents. So you're going to look at the exponents. And sorry, I'm using my phone as a light, so that's why there's a weird shadow on it. So if we're looking at these two, the one with the greater exponent. So if I had 6.23 times 10 to the 14th, and 14 is a large number, but I'm going to go ahead and move the decimal that many times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I would have 6, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'd have 623, whatever that is. And then if I move this decimal 12 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I have, I'm going to start backwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And then 2, 1, 9, 8. So if I was trying to decide which of these was larger, this one is larger. Even though if I look at the part in scientific notation, the 8.912, even though that part is bigger than the 6, since I would have to move the decimal 14 times, and this one I'd have to move 12 times, this number has to be bigger because it has, it's a larger number. Or if you remember, I would be multiplying by 10 times 10 times 10 times 14 times, and this one would be multiplying by 10, 12 times. So the one with the greater exponent will be larger. Okay, so again, first thing you want to look at is the exponents. And when you're looking at those exponents, you will see that this number is bigger. Okay, sorry, I just hit the iPad. And then if you look at the second part, it says if the exponents are blank, compare the decimals. So if the exponents are the same, so if we have 3.28 times 10 to the 5th, and let's do 4.15 times 10 to the 5th. So if we're going to compare these two, and you have 3.28 times 10 to the 5th and 4.15 times 10 to the 5th, the first thing you're going to look at, again, just like we set up here, step 1 is compare the exponents. So if we look at the exponents, 5 and 5, we notice that they're the same. So then if the exponents are equal, compare the decimals. So now we can look at the 4.15 and the 3.28, and you want to see which one's bigger. So if you look at the 4.15 and the 3.28, you'll notice that this one is larger. So this number being larger, when the exponents are the same, means that this number is greater. Because if you moved it 1, 2, 3, 4, 5, it would be 4, 1, 5, 1, 2, 3. And this one would be 1, 2, 3, 4, 5. 1, 2, 3. So it'd be 3, 2, 8, 0, 0, 0. So the 328,000 and 415,000, we would know that this one is greater. Remember, that's a greater than or equal to symbol, which you probably haven't thought about in a while, but it's a greater than because the larger part is opening towards the 415,000. You've probably heard someone talk about an alligator, and they always say, oh, the alligator eats the bigger number. I really don't like saying that, but I know that that's what a teacher's probably used in the past for you, so it probably helps you to think about that. But the larger number is the one that you want it to open to. Okay. Then another thing that you'll see is you will hear us say order from least to greatest. So if you have a whole long list of numbers, so if I have 2.81 times 10 to the negative 7th, if I have 2.01 times 10 to the 3rd, if I have 2.725 times 10 to the negative 7th, and then I have 9.45 times 10 squared. Oh, sorry, I was not over far enough. Okay, again, first step you're going to look for or look at is all of the exponents. So we have negative 2, 3, or I said negative 2, I'm sorry. Negative 7, 3, negative 7, and positive 2. And it says in order from least to greatest. So we know the smallest number, and always think about a number line. So 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So the negative 7s would be here. There's 2 of them. The 3 would be here, and then the 2 would be here. Now, even if this was a negative 2 and a negative, even if this was a negative 2, I kind of like to put these dots on the number line just to help me. Some of you guys are really quick to be able to do that. But so I have 2 negative 7s, I have a negative 2, and a negative 3. So we know we are going to have to look at this one differently, but then we know that it goes 1 and 2 in some order, 3 and then 4. So this one is going to be second, so 9.45 times 10 squared. The next one, the last one would be 2.01 times 10 cubed. Now the next thing, or where I have to go with next, is I need to look at the 2 with the negative 7s. And I need to look at these 2 numbers right here. So if I have 2.81 and 2.725. Think about money. If I had $2.81 and I had $2.72.5, the 2.81 is larger than 2.72. 72 is smaller than 81. The 2's are the same, so then you have to start looking at the decimal places. And this one would have to be first, and this one would be second, because that's smaller, and we're still, again, least to greatest. So it'd be 2.72 times 10 to the negative 7th, and 2.81 times 10 to the negative 7th. And that would be how you would order them from least to greatest. There were 2 negative 7s, so I had to look at these numbers first. Oops, I forgot to write the 5. Let me squeeze that in there. And then I would have to do the one with the squared, and then the one with the cubed. Okay, so that is how you would compare numbers in scientific notation.